Hello. In this video, I'm going to comprehensively look at the Orlando annual average rainfall, and these are contrived numbers, but it's a data set that I want to look at comprehensively. So by that I mean, make a histogram, also look at the 5-number summary and a box plot, and look at how normal curve calculations would fit in with this, and put it all together for some conclusions, like how useful is this? That's what we want to look at, is the usefulness. So first, let's start out with the histogram. So I have to make a decision of what it is I'm tracking and then who possesses it. So when I look at this, and this is very likely how you'd see this on the internet or wherever you're looking it up, you'll be given data values and the year in which they occurred. So like you would read this and say in 1973 there were 45 inches of rain on average in Orlando, and so on and so forth. So what I want to know is how rainy it is in Orlando. So I will be tracking the inches of rain, right? And then the who is technically Orlando because the rain falls on Orlando. But the way we humans measure this, and this is how the measurements were taken, is by year. So really it's the number of years. That's a frequency. So that's what's going to be on my y-axis. So on my x-axis I'll have inches of rain, and on my y-axis I'll have number of years. All right? So then what I want to do is either by hand or we're going to do it on the calculator. I'm going to put everything in the calculator. So I'm going to go stat, and then I'm going to take a look at this, and I've already got it loaded up in L1, right? And then I want to go ahead and let the calculator give me the histogram. So I'm going to go second, y equals to access stat plots. Make sure the other stat plots are off. Either all three can be off or just one is on and the other two are off. But go ahead and enter, come down to type, and then select histogram. And then over here, if you don't have your information in L1, go ahead and select whichever list, and ours is already in L1. If it were not, I'd do second 1. By the way, I just want to address the, if you happen to have a question, why do I not want a bunch of plots on? If you have 2 plots on, and you don't have 2 lists that have values in them, your calculator will not move forward. It will keep waiting until you give it the second list of values, and you'll wonder why it won't work. So I just avoid that problem. All right, from here I want to automatically have the calculator give me the picture. So I'm going to go zoom, and I want zoom stat, so zoom 9. And there it is. So I'm going to press trace here to see and read. And what you see is there's 4 values in that first pile that are between at least 32 inches and just under 40.83388. Very uncomfortable, but a nice picture. So I want to go into window and just sort of adjust these to make them easy to read. So that's what I have here, where I'm asking you to go ahead and sort of tell me what you would think would be a good window. So you might want to pause and do that, and then come back. So what I would do is instead of 32, I would choose 30. And then because I know my data values and my highest data value is 85, I would go ahead and go to 90. But if I didn't know my data values, I'd go to 95 because I wouldn't be sure, and I want to make sure I don't miss a data value being, plotted. So I'm going to go to 90, but normally I'd go to 95 if I didn't know my data values. And instead of 8.83, I'm going to use a bin width that's very user-friendly. Right? I want all these things, these numbers that I'm adjusting to be multiples of 5 or 10. So I want to go to 10. I could use 5, but that's going to be a lot of columns, right? Twice as many columns. So now I'm ready to see it, and I want to go ahead. So I changed my bin width to 10. So now I want to go ahead and press Window. And now I can see this pretty easily. If this had been cut off, like if I had seen like the line had been here and I'd cut off part of this column, I would increase my Y max so that I could actually see the top of the column. But now I want to press trace again and read this, and I can see that here in this first column there's 3 values where the rainfall was between 30 and just under 40. Much easier to read. All right, so what I would have then, as you can see here, I have a little dash mark here to say I'm not starting at 0. I have bin widths of 10 all the way through until I'm done with data values. And then my inches of rain on the x-axis, number of years, right, my frequency. And then I like to go ahead and shade my columns and put the numbers on them because you always want to make it as easy as possible for the audience to read this, right? We're all so busy and stressed. We don't want to have to take more time. Make it easy. So if I'm reading this, I'd say there are 3 years in which there was between 30 and just under 40 inches of rain. Okay? So now you can see what the histogram looks like. And then if you're going to describe it, it looks like if you were to smooth it out, right, it would be unimodal, the modes between 40 and 50, right? And again, I'm including 50. Technically 50 is in the other bin. You could say 40 and just under 50. The range is between... is 60. It's 90 minus 30, which is 60. Or if you know the actual data values, you can just subtract them, which is like 85 minus 32. You have a gap here from 70 to 80 and a probable outlier from 80 to 90. So let's take a look at how I would describe that. So here we go. I'd say there's your unimodal, 40 to 50 skewed right, range here, or 53 if you actually have the data values. And then just say a blurb, since 1973, the typical amount of rain in Orlando has been between 40 and 50 inches of rain, but Orlando has seen as little as 32 inches and as much as 85 inches of rainfall in a year. However, 85 is not a typical value, as the next highest amount of rain was 68 inches, right? So that's for the histogram. Now let's take a look for the 5-number summary and box plot. So let's say I'm going to make this easier on you. Obviously by hand you'd have to arrange all the values in order and then start doing your cuts. Your calculator can help you with that. So if I go back to stat, and then if you look at edit, it has sort ascending, sort descending. So let's say I want sort ascending, and then it asks you which list. So I'm going to second 1 to tell it sort in ascending order list 1. Press enter and it tells me it's done. When I go back in, now I can see, look, everything is nicely in order. So here you go. Here it is in order, and you're going to do your cuts. There are 30 values if you count them. So 30 divided by 2 is 15. Right? So the average of the 15th and 16th values, right? So that would be between 49 and 50. You would add those and divide by 2. You get 49.5, which then leaves you, if this is your median right here in between them, 15 values to the left of the median and 15 values to the right of the median. So 15 divided by 2 is 7.5. So you're going to round to the 8th value, but it's going to land. So it's going to land on a data value because it's an odd number. So 1, 2, 3, 4, 5, 6, 7, 8, right? Or you can go this way. 1, 2, 3, 4, 5, 6, 7, 8. In any case, here it is. Q1 is 45. Do the same thing here. Q3 is 58. So there's your 5-number summary. Let me zoom in on that just a little bit. So here's your 5-number summary. And then if you're going to plot this thing, and I like the modified box plot, so you could see if you've got outliers, you want to calculate your lower fence and upper fence. There's your calculations. And what you could see is your lowest value is, your minimum's 32, your lower fence is 25.5. So obviously there are no lower outliers. But your maximum value is 85, which exceeds the upper fence, 77.5. So I know 85 is an outlier, right? All right, so what I would do then is go ahead and make my box plot. Now, one thing I've done here, and this was deliberate. I have, for my box plot, my modified box plot, I have used or aligned it to the scale of the histogram. That's purposeful. So if this is 30, I'm just a little bit past it with 32, and here's 50, and I'm just right there at 49.5, and so on and so forth. Here's 85, right? That's purposeful. So the reason is so you can kind of compare them. So you can see this is, again, skewed to the right, and it's got an outlier. But what you can see, too, is you could see that the range is about the same, right? Right here. You could see that most of the values, the 2 tallest piles, are right here with the 50%, middle 50%, right? You can see that. You can see there's a gap, right? And then there's an outlier. So you see how much there is in common, right? And of course, these are quartiles, right? First 25% of values is between 32 and 45, and so on and so forth. So that's kind of nice because now you can kind of compare them and see what they're telling you, all right? So then the other question I have for you is, now let's go and extend this and look at what would the normal curve calculations tell you. So what you would do is in your calculator, right, you would want to go stat, but here you want to do calculate. You want to calculate a mean and a standard deviation. So calc, and then you want to stay on one variable statistics. And let's see here. Here I have stats wizard on, which I don't like, so I'm going to turn it off. So I'm going to go to, let's see if it does calculate it actually. It does, so that's easy. Sometimes I turn it off, but anyway, here we go. That was just easy to do that. But here's your mean, 51 point, I'm going to round it to 1. There's that. Here's your standard deviation, 10.98. So I went ahead and made it 11.0. I rounded to the 10th place, right? And now I'm calculating my intervals, right? Now, when you get to your calculations, what you want to do is say, well, I'm going to calculate the mean plus or minus 1 standard deviation, the mean plus or minus 2 standard deviations, the mean plus or minus 3 standard deviations. Now, why am I not using mu, which is the mean for the population, and sigma, the standard deviation for the population? Because I don't have a population. I only have 30 values. There's a lot more rain that's fallen on Orlando than just those 30 years. So I am actually working with a sample. Y bar is the average of the sample of values. S is the standard deviation of the sample of values, right? So if I were dealing with the population, I would write mu plus or minus sigma s, right? 1s, that kind of thing. But anyway, so here it is. My mean, 51.1, plus 1 standard deviation would be 62.1, so I rounded to 62. And then my mean minus 1 standard deviation, right, gives me 40. So my first interval is from 40 to 62. And so on and so forth. So what I've got here is that. So what I did is I put sort of a normal curve underneath, again, aligning everything. And here's 40 to 62. So you could see if this were normal, then 68% of my values should fall between 40 and 62. And then 95% of my values should fall between 29 and 73. 99.7% of my values should fall between 18 and 84. Well, you can already see there's nothing here, right? So we know it's not really normal. But remember, we said it wasn't really normal because we said it was what? Up above. When we first described this, we said, oh, guess what? It's skewed to the right. There's an outlier. So we know this is not normal. So why did I go ahead and do this? Why did I go and do all this work just to show you, well, what if I were to apply the normal curve to this? All right, so because what I asked students to do previously is to go ahead and calculate the actual number of values that fall between your intervals. So for example, if my first interval is 40 to 62, right, then what I would do is I would go like this. I would go to my data values. Let me show you the whole thing. I would go to my data values and then say, okay, is 45 somewhere between 40 and 62? Yes. So count 1. Just start counting. Is 46? Yes. Is 46? Yes. Is 38? No. So I don't count it. Is 51? Yes. So I basically just tally the number of values that fall between the first interval, which is between 40 and 62. And that's how I got here. I got 22 out of the 30 values, or 73.3%. And then from 29 to 73, I got to include all of these plus the ones that are between 29 and 40 and then between 62 and 73. So it comes out to capture 29 out of 30 values. And even here from 18 to 84, you don't capture that last value, 85. That outlier is not caught by that third interval. So here's the actual percents versus the theoretical percents, right? So this is the empirical rule, the theoretical, 68, 95, 99.7 for 1 standard deviation, 2 standard deviations, 3 standard deviations in both directions. But here's your actual. So you have to decide, well, is this really far or not? Would I want to use the normal curve or not on this? Because if you want to calculate, well, what percent of the time is there, let's say, more than 60 inches of rain? Well, if this were a normal curve, you could just find a z-score and boom, put it in normal CDF and you'd be done. It'd be easy. But can I do it? That's the thing. Theoretically, can I do it? Well, there's actually 2 answers. it depends. If you don't need a lot of precision, this is a skewed right distribution, but it's not horribly skewed. It's just kind of slightly skewed. So if you don't need a tremendous amount of precision, then you could say, yeah, I would feel comfortable using a normal curve. Why? Because look, the difference between the mean and the median, right, is only about 1.6. Because normally if you have a symmetric, if you have a symmetric unimodal distribution, the mean and the median lie directly on top of each other. But if you don't have if you have a skewed distribution, let me draw this out for you so you can kind of see it. If you don't have a symmetric distribution, right? So if you have a symmetric distribution, here's your symmetric distribution, your mean and your median fall right on top of each other. But if you have a skewed distribution, so let's make it kind of skewed here. Well, here's your median somewhere, right? Whoops, sorry. Somewhere in here. But because you have some outliers out here, your mean gets pulled toward your outlier, so your mean is greater than your median. So it might be here somewhere. So you have a difference between your median and your mean, and you want to know, well, how far out? So the more outliers you have, the more the mean gets pulled further out, and the bigger the difference between the median and the mean. So you do want to actually compare the difference between the median and the mean to see how skewed it is. So if you look at this, let's go back then. We see that there's a 1.6 inches of rain difference, which for a lot of people, that's fine. That's not a big deal. So I could use the normal curve calculations and know that I'm going to be a little off. But now if I need a tremendous amount of precision, then I'd say I'd not feel comfortable, right? So because of the outlier and it's skewed too much, and maybe for me, 1.6 inches of rain is way too much. I need more precision than that. And then I can't use the normal curve. Okay? So it really kind of depends on your application. All right. Well, thank you so much for listening.